Hey Chem Kids, it's Mr. Consolino here, and we're going to start our first sort of chunk on significant figures. So before we really get into how we can do addition and subtraction and multiplication division with significant figures, the first thing we have to figure out how to do is basically identify what a significant figure is, or where they are, and how many significant figures does a number have. So first, with measurements and significant figures, whenever we make a measurement, we always record the known certain digits plus one extra digit. And we'll talk more about this tomorrow, but basically that becomes a significant figure. So in this case of the ruler, our known is 0.3, 0.2, or 5 centimeters. A certain digit is anything that you can read directly from the instrument itself. So basically, if you have a ruler or you have like a beaker or something, it's whatever's marked on that beaker. So if you have like your measuring cup and it marks out 1 cup, 2 cup, and 3 cup, well, 1 cup, 2 cup, and 3 cup are known digits. We know them. They're certain. We know what they are because they're marked on our actual ruler. Estimated digit is basically a digit that we determine by reading in between the lines. So, let's say we have our measuring cup and it's labeled at 1 cup, 2 cup, 3 cup, and let's say like our water is right here. Our certain digit would be 2, but if we wanted to measure that, we say, well, it's really in between 2 and 3, so it's probably 2.5. This is our certain digit, which I'll do as CD. This is our estimated digit. We'll talk more about measurement tomorrow, but that's how we determine significant figures when we measure. Now, a significant figure is the certain digits and the estimated digits of any number. And these are the numbers that are important. They're significant. They're what we care about. Any number after that, like going back to that measuring cup example, yeah, it's 2.5. But that's really all we can say. We can't say it's 2.51 or 2.52 or 2.49. No, we can just say it's right around 2.5. Anything after that 5 is insignificant. We don't know. It's not important. It doesn't really matter. The number of significant digits or significant figures tells you how precise our measurement is. So basically, the more significant figures we have in a number, the more precise that number becomes. So, if we say it's 2.4437857 and all of them are significant, that is a very, very precise number. So in this case, let's say we have our number is 24.21. And we know that that has 4 significant figures in it. And we'll go more about how we identify the number of significant figures. But because it has 4 significant figures, that means that our measuring device can read up to the 100th place, which means we can be very, very precise. The more digits, the more accurate and the more precise our devices are. In this case, we have different scales. So we have one scale, which is something like we might use in our classroom that reads to 0.0. So we can get probably 2 significant figures, sometimes more, depending on how many numbers are actually there. But we can go all the way to the 10th place. Or we got this guy here who can be very, very, very precise. It has more significant figures. The number, or the preciseness of your measuring device is basically a property of that device. It'll tell you that it reads to the 0.00000 place, or it reads to the 0.0. Now, the most important thing with significant figures is being able to identify which figures are significant. And we actually have 4 rules that we need to know. First rule is that any non-zero number is always significant. So 1, 2, 3, 4, 5, 6, 7, 8, or 9. All those numbers are significant, no matter what. There's no exceptions to that rule. So in this case, our example is 34.65. That has 4 significant figures because there are 4 numbers. Let's say we had the number 356.789. Well, these are all non-zero numbers, which means they're all significant, which means we would have 6 significant figures. The next rule is zeros which appear in front of a number are never significant. So if we have a whole bunch of zeros before we actually have a non-zero number, none of those zeros are significant. In this example here, we have 0.0039. Well, that's not significant, this zero is not significant, and this zero is not significant. The 3 and the 9 are the only significant figures. So in this case, we're going to have 2 significant figures and disregard that 3. And the similar is like, let's say we have 0.00000003. Well, because all these all these zero numbers are in front of a non-zero number, that means none of them are significant. So this would only have one significant figure. Rule number 3 is zeros between non-zero digits are always going to be significant. So if you ever have a zero sandwiched in between a non-zero numbers, that zero is always significant. So in this case, the 0 in 0.304, the first zero is not significant because it's in front of the number. But the center zero here is significant. So this number here is going to have 3 significant figures. If we look at 0.023, well, these two zeros are not significant because they're in front of the number. However, the 0 in between the 2 and 3, because it's in between two non-zero digits, that now means that it is significant. So this, once again, is going to have 3 significant figures on it. And finally, the last rule, and this might be one of the more tricky rules, is that zeros that come at the end of a number, sometimes they're significant, and sometimes they're not significant. If there is a decimal present anywhere in the number, those zeros will be significant. If there is no decimal in the number, the zeros at the very end will not be significant. So in this case, let's look at this example here. 980. It has a 0 at the end, but because there's not a decimal there anywhere in the number, we only have 2 significant figures. Whereas let's say we did this and we wrote it as 980 point, which is okay in chemistry. This number would have 3 significant figures because it has that decimal point there. Same thing goes with this 0.1800. Because there's a decimal, these zeros at the end are now significant. So we have 4 significant figures. The number 1800, because there's no decimal there, it only has 2 significant figures, and those are the 1 and the 8. So now we're going to go ahead and take a little break, and I want you to go and I want you to fill out the Google form. The Google form that can be found on Canvas by clicking, can't spell today, by clicking that little next button in the bottom of the corner on your Canvas screen.